Hello, all. Welcome to another episode of AWS Show and Tell. I am Anil Nadiminti, your host for today. We have Mani and Akarsha joining us. We'll do introductions in a second here, but we are doing a deep dive series on AgentCore. Before we get into the details, again, I'm connecting from Princeton, New Jersey. Um, Again, we'll go into introductions. I'm a senior solutions architect supporting enterprise customers in the Greenfield area within AWS. Over to you, Mani.
Hi, everyone. Very nice to be here. I'm Principal Generative AI Specialist Solution Architect at AWS and primary line with AgentCore.
Perfect. Hi, Manny. Hi, everyone. My name is Akarsha, and I'm a data scientist, a Gen AI data scientist with Agentic AI org of AWS. And I'm working very closely with AgentCore Memory, and I'm very excited to share all the details with you all here. And
Excellent. Thanks, Mani and Akarsha. So, where are you connecting from, Mani?
Oh, I'm connecting from Orange County near the LA, Los Angeles area.
Okay, yeah. Akarsha?
I am very central in New York. I'm in
Ah,
Manhattan, the midtown of Manhattan.
okay, so we have both coasts. Yeah, so excellent. So, getting into the episode today, we are going to dive deep into Agent Core Memory. We've been doing this series, deep dive series on Agent Core, different suite of services that Agent Core offers. And today's episode, we have Mani and Akarsha joining us. So you might be using or building agentic applications, and memory is a central component of this, right? So Mani and Akarsha are going to dive deep and explain, break it down for us how things work. So we let the specialists give overview about this, right? So yeah, take it over.
Sounds
Thank
good.
you. All right. So, we are today going to talk about AgentCore Memory, which is a service for agent memory management. AgentCore Memory makes it easier for developers to build context-aware agents by eliminating the complex memory infrastructure management, right? While providing full control over what exactly the AI agent remembers. So, first of all, before we go into that, why are we talking about this at the moment? Because till 2025, till today, we have focused on creating technically amazing agents, providing them with a lot of tools, with a lot of capabilities. But however good agents are in giving human-like responses, they are fundamentally stateless. Think about it this way. So imagine every time you talk to a friend and they forgot everything about your previous conversation. That could be frustrating.
Won't be good, right? So yeah.
So, the fact remains that the ability to remember is the foundation of our meaningful human relationships, right? We remember the past conversations, we learn preferences of our friends over time, we build that shared context, and that's what deepens our connections. And this is what we want to replicate in our agents to provide truly great user experiences. We need our agents to remember things, the preferences, your important facts about you, the patterns of how you like to interact. And that's what matters. That's what will drive the user adoption for the applications. So that brings us to what I believe is going to be huge. And not just me, it's a clear consensus for what agents, for agents right now, that in 2026, it's going to be the year of context engineering. So
I think we need to dive deep into this context engineering topic itself, right? So it's huge. It's going to make a fundamental shift, impact on everything that's agentic in nature.
I completely agree. Think about it, right? We have all of these different kinds of context that we can give to our models, and we can engineer it so many different ways. And that context is the only thing that impacts how brilliant a response we're going to get, or are we going to get complete hallucinations? So this is especially critical for AI agents because, let's be honest, they're handling pretty complex tasks today, right? We can have long-running sessions that can go out for hours, and we are providing them with so many tools. And that feedback piles up in that context window as well. So here's what we've observed. Most of the times when these agentic systems mess up, it could be one of the two reasons, right? It could be either the model itself, but to be honest, models are getting so much better. So that's not that prominent a reason anymore. So moving to the second aspect, which is the context itself. So what we are providing, and that impacts how much a model is going to hallucinate or how accurate responses, how good responses it's going to provide.
So there's a quick question, Nakasha. I think whenever we go into these customer conversations, one thing that everyone asks is like these days, because you have touched based on this model thing, right?
Mhm.
So these days, models can handle like millions of tokens of context. So
Yeah.
why are we talking about context? Because even if I provide like all these documents, tool calls, and everything, comprehensive instructions,
Mhm.
model can handle really long context. So, what is it driving? Because this is a common question, and I'm putting you on the
Yeah.
spot. But
But so I mean, it is it can take in so much tokens, but then this also maybe misguides it if we are providing it the wrong context, or it is not able to derive the right information from that context, it can maybe go into the wrong direction. And that's where we have to make sure that, if we want our agents to perform really well in all cases, in all corner cases as well, we want to make sure that we are providing everything that is cured out for the agent. So we are making sure that the context window is precise, accurate, and complete.
yeah, and also additionally, like even if they can handle millions of tokens, imagine every call you are giving millions of tokens. What about the
Yeah.
cost?
Oh,
Exactly,
oh,
right? The input cost.
yeah.
So
Caching may come to the rescue actually over there, right? So caching may help, but again, yeah, there is
I mean,
different aspects.
caching will only help when it's repetitive information, which
Right.
in most of the cases, like if you're talking about user messages, if you're talking about tools, this is not always the case, right? It might take in different pieces of information. So, yeah. Uh,
I think
Okay.
the
And
bottom line is to have the relevant context every time. That's it.
Yes. Yes, 100%.
yeah, we have a
And
question coming in from Raghu asking, to share some real-time use cases as we speak about this.
Sure. I think I can take up this one. So some of the real-time use cases, for example, if you have a customer support agent, right? And then you have been talking to the customer support agent for quite some time. And that customer support agent can fetch some tools, such as some of the data APIs. And then it can also get information from your vector stores. And by the way, RAG is still alive. So not going anywhere. And because you always have these documents, right, which your company, which reflects your company brands, those are the policy, can be policy documents, can be to provide additional context. So the agents, even if you give like ask like one question, and if they need to fetch information from these various tools, it can really grow. And at the same time, you want to make sure that you're providing personalized responses to your users as well, right? So that's the main reason why it becomes really important to provide the most relevant information to your agent so that it can provide you with more accurate results and the responses back. So, one example is customer support. Now, think about another example if you're doing deep research. Now, this is a long
Mhm.
running agent, right? It's
Mhm.
running for, let's say, 5 minutes or sometimes even more than an hour, depending on the use case and how you have designed it. So, this context can grow really big. And again, if you provide too much context, think of like, I'm a human, I can only take so much. I know AI models can take more, but still, if I still have to filter out what is relevant, what is not relevant, and then you are adding this extra load to the model to figure out what's relevant, what's not relevant, right? So the idea is while you're designing your application, make sure that you're providing the relevant context. Design your application in such a way that it always provide more relevant context to your agent. And I think this is great that we're talking about context engineering. I think we should also focus on where memory plays a really important part in the context engineering. These user messages, this message history, all of those, among
The
other
chat
things.
histories, right? The
So,
chatbot chat histories. Where are
exactly.
they going?
Exactly. I mean, we have been talking about RAG and prompt engineering for a while now. So today, let's focus on memory.
Exactly. And you have to make sure that there is contextual intelligence embedded into it. Because if you provide accurate and relevance context, that's what will lead to more accurate and relevant responses back. So it's literally like the principle of garbage in, garbage out still holds true, no matter how smart the models become and the stuff like that. So it's important to do that. And also, while you're working with these applications, it's super important. Sometimes I also touched based about personalization. I want my agent to remember to give me a better response so that I can connect with my application all the time. If it remembers my past conversations or even just like my preferences. So, for example, if I'm coding all the time and if I have to give instruction that I like to code in Python, then that's like repetitive input that I'm providing all the time. Why not my agent can remember that I code in Python, right? So just one example of user preferences, it can go even big. And then also like retaining some of the knowledge while I'm interacting with the agent. So it should have like a way where it can evolve and solve my problems and understand the process and the mindset on how I like my responses to be, because I'll be keep asking follow-up questions and so on. It goes on and on and on. So all of these things are important. Like we don't have to just remember, we have to be smart about what our agents are remembering.
We have a question coming from the Twitch chat asking if this is a presentation or if it's if it includes demo. This is a show and tell series, folks. So which means that we're doing the tell part before we do the show part, right? So it's like the other way around. But we wanted to set some background before we go into
Yeah.
the demo and share more information about that. All right,
Yeah.
let's dive into this short-term memory, long-term memory. I mean, there's already memory. Can you break this down for us? What is this? Right?
Yeah, absolutely. And short-term memory, think of it as raw memory. Like when I'm talking to the agent, there are like ongoing conversation that I'm having, and I want to store and retain that ongoing conversation, which will include the user question that the user is asking, the response that the agent is giving back, maybe sometimes tool information, and most importantly, I might want to store my agent state so that it can resume from that if something goes bad, right? Or also I might want to do checkpointing to make sure that I can resume from that particular state and I can retrieve those messages while I'm talking to the agent. And then this is like when we are talking about short-term memory, there are two things that are very important. One is who the actor is, like who these messages belong to, and I'll do a little bit deeper dive into that in a moment. And then also we'll be calling, like when I'm talking about raw memory or short-term memory, I'll be using the term events. So that just shows that I'm talking about short-term memory. So that's what the idea is. Like within a session, for that particular actor can be a user, can be an agent, can be a combination of the actor and the user ID, any unique ID to reflect that. So this is the idea, is that it's within a session, right? The long-term memory is more like where it can maintain the processed information, like whatever intelligent processed information, not just the raw messages. Like, for example, if I'm saying that I like to code in Python, then it should be able to store that and it should be able to remember that across many sessions, right? Or maybe I want to provide a summary of my previous conversations from the previous session so that when the user returns back, there is a better experience for the returning user, where the user can say, where the agent can say that, you know what, oh, we talked about this particular thing last time when we met, and do you want to continue with that, or do you have something new in your mind, right? And I'm
So if
just
you
giving ideas.
Yeah, so if you take an example of a travel booking, Portal. Maybe let's run with this particular, what is short-term memory and what's long-term in that context, right? So
Yeah.
you want to,
So if you're talking about a travel agent, let's say I provide information. I just ask a question to the agent that I'm planning a vacation from November 5th to November 10th, and I want you to give me some options of the cities, and I like the beaches, and I love, you know, maybe small cabins in the forest or on the hills, something like that, right? So those conversations, literally like my question, the agent responds, the agent will pick up will call some tools to get the relevant information. So all those things will go into the short-term memory. Now, in the long-term memory, we'll extract the information, process it from the short-term memory, and store, user preferences. User likes to go on a vacation and beaches, right? So maybe some water activities might be interesting, right? So it will keep saving the preferences which I'm providing in the short-term memory while talking to the agent. So it will basically extract that information from short-term memory and store it in the long-term memory. And it can also, like, based on the strategy that you're using, it can also summarize that information. So we also have like session summary, which is one summary per session, and it's like a rolling summary. Summary. So that would be one example.
excellent.
Perfect. I think maybe this would make a bit more structural. So as Mani was already talking about, right? We have short term acting like the raw storage. It's capturing everything that is happening right now, the user interaction, the session attributes, and you can retrieve all of this instantly. So this is kind of real time, right? It can act as your agent's working memory essentially. And here's where it gets powerful. These events are also being processed through a memory extraction module and being stored into a long-term memory as memory records. So this could be, the learned facts or concepts based on how you configure the long-term memory to be like. So, the first question comes in, why should I use AgentCore Memory? So first of all, it is completely serverless with minimal setup needed. So we are talking about literally a couple of lines of code here. Plus, we got built-in encryption because, let's face it, we are dealing with user data here, and we need it to be secure in transit and in rest. And also we give flexible namespaces, so you can define how do you want the memory to be shared across different agents or across different users. And we also have flexible time to live settings, so you can basically define everything and it's all in your control. And of course, there's logging, so that you can observe everything that's happening behind the scenes. So before we go in a bit deeper into what short-term and long-term looks like, perhaps we can understand the concept first and then go a bit more.
Yeah. So with AgentCore Memory, like we're talking about short term, and I've already explained when I talk about events, they're literally like raw messages, right? And before you do or write any messages, you first need to create the memory resource itself. So we have APIs, which we are going to show you the demo of the create memory. You just need to know about that. You don't have to worry about the underlying storage. And also because the short-term memory has different properties. So the storage for short-term memory is different from the underlying storage for the long-term memory, right? So in any ways, what you have to do as a developer is basically just focus on the APIs. It will automatically spin up the infrastructure behind the scenes and give you the memory ID. So memory ID represents the related memory resource, because you need to have some space where you will write your messages. So that's literally the memory ID. Then actor ID is the identifier, like who these messages belong to. Now it can be like a user ID, agent ID, or a combination of both. And in some cases, I've even seen people using project ID in combination with the user ID. So it really depends on your use case and how you design it. we are providing you with all the constructs to help you design your application effectively. And session ID, very simple, like group of related events together. And again, you have the flexibility to define your session. You can define it by related events, or you can define it by the time period. So the main idea is to group these events together. The payload can be a conversation, like a user message, agent message, or it can be just a JSON blob, right? The blob which it can store the entire state of the agent. And we also need like a timestamp to understand when these events are coming up, right? So those are basically when you call or when you create the events, that's when in the response you can pass in on it, or it will retrieve back as well. And then branch. I really like that thing because it basically supports the alternate paths. Now, what do you mean by that? So let's say you are designing a AI assistant, right? And Anand already mentioned about, let's take an example of the travel assistant. So I'll continue with the travel assistant example. Now, let's say you are saying that, okay, one option is that I want this agent to to give me ideas about beach vacations. Another is I also like hiking. So what about those mountain locations, right? So it can have like alternate paths, but how do you design that? So for that, we have a feature called branching, and where you can, which enables like advanced event organization. So if you don't provide the branch, everything goes in the main, but you can literally call the create event, provide your own branch, and then you can have scenarios like when you have to edit a message, or when you have the alternative conversation paths, concurrent event streams, for example. So you can use branching. This is a very nice construct and a tool that we are giving you in your back pocket. So when you design your agent applications, think about branching.
So it's more like, these are my favorite: foods going to the foods branch, travel going to travel branch, right? So
Yeah. You can organize it. And also sometimes think about like multi-agent interactions. So again, talking about the travel agent, maybe I only don't need the hotel or the location. Once I finalize that, I also need the flights. So maybe there is a flight agent who can work on the flight branch. The hotel agent can work on the hotel branch once I've provided them the location where I want to go, right? So they can work parallelly as well. It again and share the same memory resource, but they have different branches that they are working on. So it's still some level of separation, of soft separation of concern that goes in there, right? So those are the areas where it's very helpful. And this is like a pictorial representation, which Akarsha, I think you'll be the best person to talk about.
Perfect. Thank you. I mean, you have covered everything, you know? This makes it so much clearer already. But I think still picture speaks louder than words, and therefore this would help. Okay. So overall, what we are showcasing here is let's say your agent is having a conversation with the user, right? It needs to have it needs to store all of the immediate context that is happening, and that is being stored in either conversational information or conversational messages, or it could be a blob. This is essentially going in as a binary piece of information. And this is where it's slightly, the two differ to some extent. So the conversational event, think of it as, chat messages, user input, agent responses, or tool messages, right? This is the piece of information that actually enriches your long-term memory. Because this is where, the meaningful interaction data lies. Second, here is the blob, which mostly stores the session information. So this is the key difference. So here, the events that are in here would not be extracted as insights later. So this, mostly includes checkpoints or session state. Now, just to clarify the difference between checkpoints and session states, I've heard a lot of people are very confused about that. So checkpoints are basically snapshots of your application state. So think of it in terms of fault tolerance or recovery. So if something goes wrong, you can pick back up right from where you left off. And session state is mostly around the user-specific data across multiple requests. So your session ID, your agent state, this kind of thing. And then when you need to work with this data, you have got simple operations that we provide, like list events or get event, to retrieve specific events that you need. And you can filter them. And to understand that, I think we will go deeper into it once. You will see it in the demo. But overall, the beauty here is that the short-term memory acts like the agent scratchpad. So it captures everything in real time, categorizing it, categorizing it properly and making sure that nothing gets lost in the process. Now, let's move on to long-term memory.
And previously we mentioned about namespaces. So now we understood, like in short-term memory, there is a concept of actor ID, there is a concept of session ID that we have talked about, and how how they are used to organize the short-term memory and to identify, okay, these are the messages that belong to my calling user, right? But what about the long-term memory? Because long-term memory, we are saying that, it keeps, extract the processed information from the short-term memory and goes into the long-term memory. But how does it really go? And how do we organize our long-term memory? Because long-term memory can span across sessions, right? So how do we organize it? That's where the concept of namespaces comes into play. So again, you are all aware of the actor ID, you're all aware of the session ID, but what about the strategy? So how do we know what to fetch from the short-term memory that goes into the long-term memory? So that is defined by the strategy. So with long-term memory, we have three built-in strategies. One is the semantic, basically just the facts during the conversation, and it will capture that. User preferences, literally as the name suggests, extracting preferences of the user. Summary is per session. I think I've already talked about that enough. Then override is basically you can so there are some user-defined extraction rules, and with this override strategies, what you can do is there are two things that comes into play. One is the extraction logic, the other is the consolidation logic. Because if my information or my preference is already stored or extracted, I don't want it to store like duplicate things. And also, if I'm updating my preference, like let's say I love to code using Python, but now I like Java, hypothetical example, it should update my preference. So that's the consolidation logic. But if I want to override that and provide my own prompts and provide my own model to do that, then that goes into the override strategy. So you can do that. So you have that option as of today, right? And then you have defined the strategy. But how do I organize? Let's say I have this user preference long-term memory that I have enabled, like I've provided that strategy. Then the namespace is a hierarchical concept where literally it's nothing more than the prefixes hierarchically arranged, which can take these three IDs, which you can provide because you also want to make sure at runtime it's able to resolve the actor. So my user preferences should only be visible to me when I'm interacting with the agent. But if Akasha is interacting with the same agent, only her user preferences should be shown to her, right? So that's the main idea. So then in the namespaces, and one of the examples that we have given on the slide is like retail agent slash customer ID slash preferences. And then you provide, and this customer ID is actually resolved at runtime because you can pass these variables. So this is just one example. So think of it as a way to organize your memory records into logical categories so that it's easier for you to retrieve it. And one quick thing, uh, one strategy can only have one namespace, and you can provide whatever namespace it is as of today. So things change in future. You never know what happens. So as
I
of today,
mean, you only need one namespace, right?
yeah, you do.
All right, so here's where things get very interesting. So now we have the full picture, and now we look at everything of how it flows. So we talked about the raw events, right? They just don't sit in there, we discussed. So there's an asynchronous pipeline, a memory extraction module, which does some pretty smart work behind the scenes. So this is the module that takes in all the raw data, and depending on the strategies that you have defined of what you've configured while you created that the memory resource, based on that, it extracts the relevant piece of information. And as Mani was mentioning, we can also override one of these strategies. Now, I mean, why would I override these? They're pretty defined, right? What else can I need? But I guess, so we were talking about this travel agent, right? Let's take it that way. So let's say when I'm building an application for a travel agent, I only want users' preferences of their, if they prefer budget hotels versus luxury resorts, or are they adventurous travelers, or they are into relaxed beach vacations. But do I care if they prefer their coffee black or if they code in Python? No, probably not. So that's where you want to override and maybe focus these strategies more onto the use case. So that's where you might want to override the prompts that are already defined in there. So, I mean, once you have it all stored, you have these long-term strategies, then you can access them via the retrieve memory record. So you can list them, retrieve them based on the namespaces that you've provided. And you can combine this with the list events from the short-term memory. So for example, one of the very common patterns that we see out there is the last n messages. So let's say the last 5 messages that you get through list events, and then you get the relevant user preferences or the relevant summary of that session from the long-term memory. So you can combine that and therefore compress the context of the agent to more or less like 60-70%, and still get good quality responses, equally good responses as you would if you provided the entire context history. So we have kept this memory extraction module a bit hidden. So let's go into this a bit. So when we...
As you this, Kasha, there's one question that's coming in from Raghu again, asking if we can set a time duration. Is it like, for example, is it possible to retain only the past 5 days of discussion? We can also cover that.
So for short-term events, you can configure a TTL where you can define how long do you want. So this can be between 7 days to 365 days. So you can configure anything in between that. Okay. Moving on to our memory extraction module. So this extraction pipeline runs asynchronously after every K messages or after every X seconds of inactivity, because we don't want it to wait for too long, waiting for more messages before it stores the summary, for example, or the long-term information. So overall, the module has 3 steps. So first of all, we start with the extraction. This is where it extracts the relevant info. And now, as mentioned here, it is per strategy. So depending on what strategies you've defined, you can define 0 or more strategies. So depending on which strategy you've defined, this extraction module will run per strategy for each of them. Okay. So first step is the memory extraction module, right? This is where we extract the relevant piece of information. So if, let's say, we are talking about user preferences, it'll only extract user preferences from all the messages that we have provided. And one thing we skipped to mention, we can provide up to 100 messages in one event, right? So it is essentially extracting only the relevant parts where the user is giving out some information about a preference. The next step is the consolidation part. So this is an interesting one. So remember, we were talking about this travel agent, right? Imagine the user mentioned in April 2025 that, hey, I like to go for camping spots. And now in October, the user is exhausted from work and they suddenly prefer beach vacation. Happens to all of us, right? But
Exactly.
this is the piece of information that we need to update and not like create two entries or remove the previous one. But we should have update of this information that's saying that, hey, user preferred um, a, a camping spot in April, but they prefer a beach vacation in October because they feel exhausted. So something a bit more complete, a bit more exhaustive piece of information, right? Instead of replacing the old one or ignoring the new one. So this is just one example of when would update be in the situation. So what consolidation step does is it retrieves similar memories from the existing vector store of existing long-term memory, and it consolidates the new memories as per what already exists. So it can add new information if, let's say, that information did not exist before. It can update it based like just with the example that I just shared, or it can just skip it because maybe that information already exists. The user mentioned in April that they want to go on camping spots and they mention it again in October. So we don't really need to update any part, right? So we can skip that part. And then based on what the outcome is, it embeds and indexes that into the long-term memory, which essentially is a vector store,
Yeah.
right?
And we have talked about vacation so much. I think all I will be tempted to go to the beach or for a walk or take a vacation. I am. I don't know about others.
Anil started it.
I'm thinking about it.
Yeah, so I mean, this way we avoid redundancy, we avoid any duplicates, we avoid any incomplete pieces of information. So we make sure that our memory is always updated, right? So we are not creating any duplicate information inside the vector store, which I would say is a very important aspect of when you are trying to remember something, right? Things get updated, things change over time. That has to be captured.
And also, it's an important thing tying it back to our context engineering stuff, right? It becomes important. We don't have redundant information in our context. That's one way tying it back to what we shared in the beginning, right? So I think now we talked about a lot of things. We talked about short-term memory. We talked about the concept of events, actor ID, session ID. How do we, fetch that information? We can filter events. We can, if you don't want to use long-term memory and you only want to use AgentCore memory for short-term, you can actually do that. And if you want to use long-term for storing just the user preferences, you can do that. So you can have one strategy, multiple strategies and all. We also talked about how you will organize your long-term memory using namespaces. So there's so many concepts that we have touched upon, and not the last but not the least, we also talked about the vacation, which all I think needs at some point in time. So, but now let's say we have talked so much about all of these things, right? And now you should be ready to deploy the travel agent Akasha. What do you think?
I agree. I think, yeah.
Okay, so let's deploy it. So, do we want
Okay.
to deploy it with runtime, agent code runtime, or do we want to deploy it with some other thing like other EKS or Fargate? So,
I
whatever.
prefer runtime. I prefer runtime.
I mean, why
Okay.
do we want to build everything from scratch, right? So,
Yeah.
Yeah.
Yeah, but
right?
there is option. That's what I want to share that you can, if you already have a deployment pipeline, we want to meet the customers where they are in their journey. So you have an option. But for now, we'll focus on the sample deployment with Agent Core Runtime because we love runtime. And that's the main idea, right?
Yeah, and since you mentioned that, Mani, just as we talk about that, now Agent Core Memory, if it's deployed in AWS, can external services integrate with Agent Core Memory?
So all of these are APIs or the SDK behind the scene, right? So you can, based on the permissions that you have defined, based on the resource access permissions that you have provided, you should be able to call it from anywhere. So you can integrate it with any framework. You can use it with any model. Only thing that I want to consideration that I want to call out is that we talked about the override strategy, and you can change your model for extraction and consolidation because that's handled by a large language model. And that model has to be the Bedrock model. But your agent can be any model. It can be like OpenAI model or a Gemini model or something or or one of our favorite models.
One of the many models that's out there.
Yeah, one of the many models, right? So that's the key idea and the tenet for all AgentCore services, and that includes memory as well.
All right.
So
Yeah, sure. Excellent. So I can't wait to get to the demo part.
yeah,
So
Okay.
enough of talk, right?
Yes,
Let's
people
get
were
into
very keen
action.
on looking at the code.
Yep. And
Okay,
also,
so
Akarsha, can you remove this left navigation so that our users can only focus on the code? So click on the folder on the top. Yep. Awesome.
yeah.
thank you. Okay. Okay, perfect. So we look at two examples, one with checkpointing and one with long-term memory. I mean, it's not that these are either or, but it's just to kind of keep it separate and show a very easy demo, right? So first we see a line graph agent being created, which has a memory. So we are using the default AgentCore Memory saver from LangGraph Checkpoint. And that is where it will by default create the checkpoints behind the scenes. So there's an automatic event store in place, and that will store all the events in the short-term memory, and we can retrieve those events through list events, and we can talk to the agent, and it can continuously keep the checkpointers in the memory. So what do we need to do for that? We firstly import a memory client. We create a memory or get memory based on the name. Maybe we've already created it. In this case, for example, we have already created it. So it retrieves a memory ID, and that memory ID we can provide in our React agent as a checkpointer, right? So the checkpointer that we have, sorry, not memory ID, we create a checkpointer using the memory saver class from LangGraph AWS. And from here, we provide in the memory ID in the region where it is supposed to store, and that we provide as a default checkpointer within the graph. So we created a very simple graph. We can just run it, and we provide when in the runtime we can provide some configuration. So two that are required is the thread ID, which is the session ID, and the actor ID. So the actor ID could be an agent level, could be on the actor, could be on the user level, could be a project ID, could be an org ID, could be a common one for everything if you want to share the entire memory resource with everyone. Could also be the case, but essentially, as Mani mentioned, this is a construct that we are providing you to use to get that flexibility for your application. So you provide in the config here, and then you send in the input, and based on that, it streams in the output of what tools it has used, what it has done.
Yeah, and just before you go further, Akarsha,
Yeah.
I want to clarify something because this is a very common question, and while you were presenting, it was literally jumping in my head, and I couldn't stop myself. So, one common question that I know that everyone has asked us most of the time, like literally 99% of the time.
Mm-hmm.
One question is, especially when we go into this demo piece, right? So one question that I get is, do I need to create the memory every time I initialize the agent? The answer is no. You
That's a very
only
good point.
yeah, because we have seen like those mistakes happening, and then it was like let me just guide it over here so that it becomes like a common practice. So
Mm-hmm.
while you are creating the memory, it's a one-time activity, right? You create the memory resource, and when you initialize the agent, you only need to provide the memory ID. And that's the reason why we have this helper class create or get ID, so that you don't accidentally keep creating the memory ID. So make sure that whenever you are calling create memory, it is creating the resource itself. You don't need to create the resource every time you initialize
Mm-hmm.
the agent. You only need to create it once.
Yeah.
In the subsequent steps, you only need to provide the memory ID. Now, question number 2, very important question. How do we manage these IDs? Because this is memory ID, there is session ID, there is actor ID. And Akasha, you have provided that in the demo, but I want to call it out so that we understand what that is. So if you scroll down, Akasha, like where you were initializing the checkpointer itself, right? Oh, that was up.
Yeah.
Over there, you were
Yeah.
providing the memory ID, right? So this is an initialization step. So when you are actually working with these frameworks, you can just provide the memory ID once, right? So that the agent knows where to store these messages. And then you need to provide the config where you were, again, providing these ID once, because once you get into the session, you need to identify the calling user or the agent. So you provide the agent ID or the user ID or a combination based on your use case, and then you pass in the session ID, right? So that goes into the config, and I think Akasha, the config is was in the cell downstairs. Yeah.
Yes.
So yeah, so that's where you will provide it, and then when you are interacting with the agent, it's simple. You just interact with the messages and all, and the agent knows that who is it talking to and which session is it in, right?
Yeah. And in most of the cases, you will see that this part where with the thread ID and the actor ID comes in from the payload that the backend is interacting with the front end with. So based on the authentication that the user has done, you would have the user credentials and user information. And based on that, usually you would create an actor ID. Versus the memory ID is something you can store as an environment variable, or you can store as a SSM parameter. So in your secrets manager or something, which you can continuously repeatedly retrieve from. So it's a constant that once you've created it, you can, use the same over and over again.
And even the session should come from your for example, if you're deploying it in the runtime or some other things, so it should come from your environment or the payload. Yeah, you mentioned that,
Particular
right?
chat session,
Yeah.
right? Yeah.
Yeah.
Yeah, yeah.
So we have 12 more minutes, just a time check,
Okay.
right? So yeah.
Oh, yeah.
Okay. So just to showcase here, what we are doing here is just like having a simple interaction. It's a math agent with multiply and addition as options, as tools. So we can, kind of interact with the agent continuously in multiple steps. And we can also retrieve the checkpoint, different checkpoints at different time that we have created. And we can also actually look at a very simple memory browser that we have created that lets us inspect. So we created this React Agent 1 as an actor ID, right? So let's configure that. And I think the session ID was session 1.
Yeah. And
So with this,
bigger? Can you make it bigger? Like,
Yeah. So
okay.
yes. So as you see, since we have checkpoints in here, we are creating events of type blob. And one thing with LangGraph you would see is that it creates the blobs of either it creates the checkpoints or it creates writes. So you can also have event types of writes, which are intermediate checkpoints that it creates. But it creates a lot of events which are of the type blob, which it can store and retrieve from. And those are the events that you basically would keep storing by default if you want to make sure that your state is being persisted.
Yeah.
And
let's go to the long-term memory piece, right? Because short-term memory is literally like this. And if you're saving the conversationals, you can see that. And all this code, like the memory browser and all that Akasha is showing in our GitHub. So you'll be able to quickly find that. And we've already provided that link. Okay.
Yes, perfect. So the second one is a bit more interesting. So here we have created a customer support agent using Strands Agents framework. And here we have provided some functionalities, so some tools that we have provided locally, and we are connecting it with AgentCore Memory. Now, what we have done, just for the demo's sake, is seeded this with some previous information. Now, we have provided this context. First of all, let's look at how do we create the long-term strategies, right? So in this case, just to show you, we have created all three strategies as options. So we define a list of a dictionary, which is the strategy type, user preference, and we define the name. This is on you. You can you can name it anything you want, with a description also editable and based on your choice, just for you to remember. And this is the important part here. So namespaces that you're providing here is going to take in a path-like structure. So it's the hierarchy that Mani already discussed or was sharing before, with one or more of these variables that you can provide. So it can be actor ID, strategy ID, or session ID. So in here, for example, if I'm talking about a summary, I also provide a session ID because my summary would be dependent on a session, right? And then for semantic, I say, okay, just divide it based on the actor. Similar for preferences, I only want to divide it based on the actor.
So
And
maybe a question here, right, is if we're doing the same travel agent use case and we have a session going on for a particular user who's interacting with the travel agent chatbot, what would be the actor ID, right? So is that the actor ID, some ID that we're giving to the user, like a user ID?
yes, so in the travel agent case, mostly it's going to be the user ID, but it can also be a combination of the user and the agent ID if we are considering branching concept.
Correct.
So it can be a mix. I mean, really depends on what use case are you building and how do you want to separate out.
Yeah.
So here, yes. So here we have the memory client. We can create or get memory, and we provide in the memory name. We provide in the description and the strategies. So the list of dictionaries that we have created here, right? So this is what we provide as strategies and an event expiry date. So this is, as I said, is between 7 and 365 days. So you can define how long do you want the events to be stored. And based on that, you will get a response. So this usually takes a couple of minutes to run, only the first initiation of a new resource. So this is going to be only for the first time when you're creating a new memory resource, not when you're creating events or getting the memories or creating memories. So that's not the case. But here you will get a new memory ID that is being created for you. And this, as I said, you can define how you want to store it. So you can put it as an SSM parameter so that you can always retrieve the same.
And I think
So
we should also call that out. This few minutes that we are talking about is only for the long term memory. And this event expiry days is only for the short term memory. For the long term memory, currently we don't have any TTL, but you can always, we provide you all the APIs where you can delete the messages based on your business use case. So I just want to call it out because sometimes people understand that event expiry days is for both. So it's only for short term memory. And also only for if you're using long term memory, it will take like about 2 minutes to create it because we are creating a vector store behind the scenes. But for the short term memory, it's really fast. Go ahead, Agatha. I just wanted to clarify.
thank you. Yes. So we have created the memory resource, and now we want to seed in some interactions previously, because maybe my agent has already interacted with it before, and therefore we can batch in the previous interactions or send them one by one. It's really your choice. And we send it to the memory client through a create event API, which takes in the memory ID, an actor ID, which in this case is a customer ID, which we have just created for demo purposes, and a session ID, which, let's say I want to group all of them, right? So I can also hard code a session, or I can take a UUID, like a unique ID that I can create for every session that comes in. It's, again, dependent on what use case are you planning to build. And then we are sending in the messages, one or up to 100 messages you can send in. So you're sending in all of those interactions and basically seeding it in so that it can process it for long term. Now it'll take around about 20 to 30 seconds for it to reflect in the long term. In this case, it was really fast. But in general, it takes around about 20 seconds, depending on how much the payload is and how many requests are there. So in this case, we have, you remember us creating 3 different strategies, right? So maybe we look at different strategies. So in this case, we retrieve from preferences, right? We call the retrieve memories API with the namespace that we provide, and we fill in the actor ID with the customer ID in this case. So you see the string that is being filled with the customer ID, and we get let's say this interaction back. So based on what we fed it in, we were talking about, you know, MacBook Pro overheating issues, my gaming headphones, I like competitive FPS games, and then we had user messages and we had assistant messages. So what the agent responded back with, and these were like 3 conversations. So here you would notice something, is that we for preferences, we get in a context, we get in preference, and we get in some categories, right? So it's the formatting that it does. So it is giving us some tags that we can use as categories of what the user, what this topic is, and some context of why did the model extract this information, or why does the model think that this is a preference, in case you want to, you know, roll back and understand how did it extract this piece of preference. So in this case, concern about laptop performance and thermal management during intensive tasks, because the user reported experiencing overheating issues with MacBook Pro. So
Akasha, can you also show like the memory browser where we can see that
that's,
information? Because I mean,
yes.
literally, they can change the name. Our viewers can change the namespace and experiment with the
Yes.
notebook themselves. And let's see how this will look in the browser so that we are clear. And
Yeah.
after that, we can quickly summarize what we have discussed.
Yeah, we are just getting
100%.
close to the end
Okay,
of
we
the.
are we
Yeah.
are we are short on time. I mean, there's so much to share.
Yeah.
So, okay. So we have, mm,
So while Akasha is, working on that, I just want to like we can talk about what we have discussed so far. So a few things that we have talked about is first we started with our context engineering. Like, why do we really need memory? We talked about there's so much focus on the technical capabilities, but what about the good experience that we want to give it to our end users, right? That's the whole idea of creating this application in the first place. And then also, how can we be smart about context engineering? How can we smart about what goes into the memory, what goes into our vector store, like your documents, the static data, and where should you call the APIs, like with real-time data APIs, where you need like literally real-time data, right? And then the memory comes into place where we talked about long-term memory, like user preferences, summary, and we also talked about semantic facts. Those are the different kind of memories, how you can override based on your business logic. And we also talked a lot about the short-term memory, because while you are interacting with the agent, that's the first piece that you need to do. You need to persist that information, those raw messages, that tooling, and maybe save the session state, checkpointing, so many things. And I'm so excited over here, and I'm very passionate about, as you can see my face when I talk. It's literally visible when Akasha and I, when we talk, like it's literally visible how passionate we are about this. So, and we really want you to go and try some of these samples. We have shared the GitHub with you, and we have also shared the memory browser. All you need to do is provide the memory ID, your actor ID, and a session ID, and you should be able to do that. And even if Akasha, you are unable to show it over here, it's fine. Our
my
users are
I
my
ready.
think, yeah, I think don't worry about it, because
We have it fired.
there's a lot to show. What we
Yeah.
could do is definitely come back and have like all
yes.
these different moving parts and show our viewers how everything connects together, right? How the Lego blocks connect.
Hmm.
But since we're at time, we'll uh, thanks for money for summarizing everything. We can't wait for our viewers to explore, experiment, and come back and ask us, uh, more about Agent Core Memory, right?
Yeah.
So with that,
Yeah.
signing off for this week. We'll join you next week again. Akarsha?
Looking forward to more questions.
Yeah. All right, fine.
Absolutely. Thank you. Bye bye. Have a great
Yeah.
rest of
Bye,
Thank
all.
you. Bye-bye.